Okay, so let's see how many examples we can get through before it punks out again. So f of x equals the cube root of x squared plus 4x, and we want to find the derivative of this. Okay, so let's think of our derivative rules that we have. You have your power rule, you have all your trig rules, you have your product and quotient. We're gonna use these two in particular each time we attempt to use the chain rule. Not to say that product and quotient won't be used as well. But first I'm going to rewrite my function so that I can recognize what this outside function is. So I have something being raised to the 1/3 power. So working from the outside in, first I'm going to have to derive that. So bring the exponent out front, subtract 1 from the original. Now remember, you can only derive one function at a time. So the x squared plus 4x, the base of the power of 1/3 has to be kept exactly the same. Then I have to multiply by the derivative of the base, the derivative of the inside. So that gives me x squared plus 4. And then just writing this so the derivative has positive exponents. 2x plus 4 on the top divided by 3 times x squared plus 4x to the 2/3 power. And that would be the derivative. Alright, if I have y equals -1 over x cubed minus 2. Now you can use quotient rule here. Right, and I know some of you in class prefer to use the quotient rule whenever you see something written like this. But I'm going to show you how the chain rule would work. So I can take my denominator and raise it to the -1st power. Alright. Then when I find the derivative, first I'm going to derive something raised to the -1st. -1 times -1 gives me 1. Subtract 1 from the original exponent. The x cubed minus 2 needs to remain the same. Then I'm going to multiply by the derivative of the inside, which would be 3x squared. So writing it with positive exponents, 3x squared over the quantity x cubed minus 2 squared. If you use the quotient rule, you can check it tonight using the quotient rule, and I promise you, you'll get the same answer. Alright. Let's look at some trig. Alright, f of x equals cosine squared of x. I'm going to do this in two ways. First, I'm going to use the chain rule. So this is equivalent to the cosine of x, that whole quantity squared. Alright, when the exponent is between the trig function and the variable, the entire function and expression are being squared. So by the chain rule, working from the outside in, my outermost function is my squaring function. 2, bring the 2 out front, subtract 1 from the original. What was the base of the exponent? The cosine of x. Then I have to multiply by the derivative of cosine, which is negative sine of x. So -2 cosine x sine x. Now the second method, you could look at f of x as the product of the cosine of x times the cosine of x. If we use the product rule, first times the derivative of the second function plus second function times the derivative of the first function. Then these are the exact same terms, so when I combine them, we get the -2 cosine x sine x. So it just goes to show that the method you choose is up to you, but no matter what the method is, we have to make sure we're getting the same answers. Alright, how about if my function is cosine of x squared? And this is a very important difference. cosine squared x, like we just looked at in the previous example, is equal to cosine of x times itself. So when the exponent is between the trig function and the expression, the entire function and expression are being squared. When I look at this problem though, cosine of x squared, that's saying it's the cosine of the expression only is being squared. So when we look at this, I can't use product rule here. I'm not allowed to distribute the cosine, and I have one function on the outside. I have my cosine function here. So now when we go to determine the derivative, working from the outside in, the cosine is the outermost function. So if you need to, include the x squared in a set of parentheses so that you can differentiate between cosine squared of x and cosine of x squared. So working from the outside in, derivative of cosine is negative sine of whatever follows it. So I have to keep the expression the same. Now according to the chain rule, I multiply by the derivative of x squared, which is 2x. So y prime negative 2x sine of x squared. Now the parentheses around the x squared may or may not be included, but you just have to be aware of the difference between cosine squared x and cosine of x squared. Alright, let's see, what did I do next? Okay, so I don't run out of room. So now that I know that first derivative was negative 2x sine x squared, now find the second derivative for me. So y double prime, now in order to determine the second derivative, we will need the product rule in addition to the chain rule, because the sine of x squared will need the chain rule. So first function times the derivative of the second function. Alright, so inside here we have to derive the sine of x squared. So using the chain, derivative of the sine function is the cosine of whatever follows it, times the derivative of x squared, which is 2x, plus the second function times the derivative of the first function. So the derivative of negative 2x is just negative 2. Now putting these together, 2x times 2x, negative 4x squared, cosine of x squared, and then minus 2 sine of x squared. So this would be my second derivative. Now you could factor out a negative 2 x squared cosine x squared plus sine x squared, but it's certainly not necessary. Alright, I'm okay with you stopping there. If you checked on CalcChat, this would most likely be the answer, so just again know that they're equivalent. F of x equals secant squared of pi x. Okay, so I'm going to rewrite this as secant of pi x. Because the exponent was between the trig function and the expression, the entire quantity is being squared. So now when I look at my x is being multiplied by pi, then I'm taking the secant of that, and then I'm squaring that whole thing. So when I derive, I have to work from the outside in. So I work towards the x. So the derivative of something being squared, 2 times that something to the first power. Okay, what was the inside of the function? Secant of pi x. So we derived that. Now the derivative of the secant function. The derivative of the secant function is secant tangent. Notice I'm leaving these blank because what follows, I don't want you to then use the derivative as well. What was I taking the secant of? Pi x. So I derive that function. Now I need to multiply by the derivative of pi times x, which is just pi. So then if we sort of cleaned up the derivative, 2 pi secant of pi x. Well, now look what I have here. I have secant of pi x times secant of pi x. So they're the exact same functions with the exact same expression that follows them. And then times tan of pi x. So it would be expected that you can get to that answer. Alright. Well, in the event that it's going to freeze on me again, we'll stop here. Let me assign a few homework problems. Okay, well, I think it's done. So I'm going to assign a few things for you to look for after the video, and just a couple problems so you can practice on your own. I'll see you Thursday in class.